All right, lesson 11.6, properties of probability distribution. Okay, so these are some vocabulary words that you should look over. Properties of distribution. So a random variable x is a function mapped the set of possible outcomes of an experiment to a real value. A probability distribution is a graph, table, or formula that gives the probability of each value of the random variable. If a set of data is fair, then the probability of receiving each entity is even. Probabilities are decimals or fractions, not percent. Unless it asks you for a percent, do not change it to a percent. All right, so the fair spinner. So this is a fair spinner. So that means that it's equally likely that you're going to be able to get yellow, blue, red, or green. Is spun one time. There are 4 possible outcomes, 1 for each color based on the picture. Which statements are true? The probability of each outcome is equal. Yeah, because it's fair. The probability of each outcome is different. Nope. The outcome have a uniform probability distribution. Uniform, which that means as likely, the same. So yes. The outcomes have a non-uniform distribution. No. All right. What is the probability of spinning a yellow? Well, it'd be 1/4 or 1 out of 4. Or 0.25. What is the probability of spinning a yellow and a green, which would be a 2 out of 4 or 1/2 or 0.5. And what is the sum of probability for all 4 outcomes? Well, it would be 4/4, which is equal to 1. Okay, experimental probability distribution with frequency tables. So probability distribution can be represented by a frequency table. A probability frequency table distribution is a way to show how often an event will happen. It shows what the probability of each event is. Okay, so again, a fair spinner. So this means that it's going to be evenly distributed and it's going to be a uniform probability. It's equally likely that each color will be spun. Okay, so this is our spins that we get. It's spun 2 times. So the first time would be red, second time red. Blue, blue, yellow, yellow, and so on and so forth. We're going to make a table for yellow, okay, as the outcome. All right, so how many times was there a yellow as the outcome? 9. There's 0 yellows. There was 9 times there was 0 yellows. And our relative frequency then would be 9 over our total amount of spins, which would be 16. Not each individual spin, but the combinations of spins. So there are 16 opportunities. Okay, and then our decimal would be 0.5625. All right. The likelihood of there being 1 yellow is 6. There's 6 times that yellow is happening. So that's going to be 6 over 16, which is equal to 0.375. 2 yellows. That only happened once. So that would be 1 out of 16, and that would be 0.0625. Using the data from our probability table, what is the probability of the spinner landing only once on yellow in the 2 spins? So once on yellow, and that's going to be 0.0625. 0.375. Okay. Probability distribution with graphs. Just like our frequency tables, it can be frequency distribution can be represented as a graph. So a 4-section spinner is spun twice, just like in the previous example. Each of the sections are the same size. So again, this is fair. The set of possible outcomes are, and then the list below. Which graph shows the probability distribution of random variables represented greens? Okay, so G is letter green. Okay, so how many times was green? 0 times. And this is a frequency. So we have to do our frequencies. So we have green, we don't have green here, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times. So for 0, we have 9 over, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spins. So 9 divided by 16 is 0.5625. So it can only be this graph because 0 is at 0.5625. This 0 is not at point, it's like 0.1 maybe. This isn't even going by frequency, it's going by number of spins, I'm guessing, because that would be 9 spins here, but we're looking for frequency table or frequency graph. All right. Finding the probability distribution, real world connections. So Addison sells 100 tickets for $10 each for a raffle. There is one reward for $100. The 4 awards for 50 and 10 awards for 30. The remaining proceedings go to hosting the contest. Which table correctly displays the probability distribution? Okay, so only 1 out of 100 people will receive the $100. Okay, so 1 out of 100 will receive the $100. That would be a 0.01 likelihood of getting it. Okay, so far, the only one that looks like it could be is this one, but let's just make sure the rest of our data makes sense. All right, then for $50, it's 4 out of the 100 people, which would be 0.04. So this is looking like it's this one. And then for 10, it would be 10 out of 100. We'll get the $30. So this is $100 up here. This is the $50. This is the $30. And that would be 0.1. And then our remaining amount of people, because we have 15 people, so that would be 85 out of 100 would receive no prize. And that would be 0.85 or 0.85. So this second graph here would be our data. Mean of probability distribution. The mean of probability distribution is typically values used to represent the center location of a probability distribution. All right, use the data table. What is P of 3? All right, so we're going to look at what our P of 3 is. Well, that's 0.2. So we're just looking at the data there. Okay, what is the mean of probability distribution? That's going to be our halfway point, so the middle of our data. So this is evenly distributed, so that's going to be 2. All right. Symmetrical and skewed distribution. So when a distribution is skewed, the statistics themselves may be unreliable. When a distribution is symmetric, this means that the mean and the standard deviation will accurately reflect both the center and the spread of the data. So, when something is symmetrical, the mean and median are equal. When it is negatively distributed or negatively skewed distribution, the mean is less than the median. And if it's a positively skewed distribution, the mean is greater than the median. If you have any questions on this lesson, feel free to ask.